Hello guys, so welcome back to the live stream and welcome to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. And today is day 69. We are going to continue from where we stopped on day 68. We literally got stuck on day 68, so I had to end the live stream and just go back and relax and refresh my memory rather. So the challenge was that, let me just continue from there real quick. The challenge was that we actually got stuck on this exploratory data analysis in Python, which is the chapter 2. If you don't know what we're actually doing here, we are trying to learn Python and master Python using the DataCamp resources over the next couple of 100 days. So we're on the data analyst in Python career track. So we've covered quite a lot, a whole lot. We've done a couple of projects. So you can just catch up on the live stream tab. Go to YouTube, Excel Island, and search and go to the live stream tab. You're going to see a whole lot of lessons, videos, and resources in the YouTube description. So you can also practice your Python skills. So we actually got stuck in this place here where we have to do following a couple of instructions. So I have my Jupyter notebook launched here. Let me just bring that up real quick. Right there. So this is the file we're working with. So what I tried to do, I tried to recreate same instruction in my local machine using Jupyter notebook for it. So I can actually be confident in what I am doing. So I actually got stuck here where we're trying to visualize this duration. We're trying to work on this duration column in this planes data frame. So we've done quite a lot from the beginning. Just go back to the live stream tab where we started this exploratory data analysis, the chapter 2. We're going to catch up on all of this from the beginning till the end. So in this case, we want to work with this, want to perform a simple analysis on this duration column. So the instruction was to visualize the first 5 rows of the duration column as it is here. But when I look at the scenario here, when I run this code, the data provided here is in decimal places and it only has one string. So let's say flight duration. You would like to analyze the duration of flights, but unfortunately, the duration column in the planes data frame currently contains string values. If you want to analyze the duration column, but it has numeric and string values, so we need to get rid of the string value. So you need to clean the column and convert it to the correct data type for analysis. Cborn has been imported as SNS. So the first instruction was to print the first 5 values of the duration column, which we did with this line of code here. And we have this result here, and the data type is objects. But when I run similar line of code in my Jupyter notebook using the provided data sets, I have it in O number with 2 strings here, which is hours and minutes, according to the data frame that we have here. Also, you can see here. So if I go to the beginning of the data frame when I got connected to it, you can also see the similar scenario here. So definitely the data camp data frame is actually cleaned for this scenario, while mine isn't cleaned very well. So I just have to go along with it and use it like that. So the next instruction is now to remove the H from the column, which is really makes sense. We only have one string here, which is the last H here, which is quite easy to remove. You just use this remove string character, you call on the duration, the plain data frame duration column, and you use the string dot replace function to remove that, which is pretty straightforward. If I try similar line of code here, I'm only going to be removing the H, not the M. It's going to affect my data frame, my data points. You see, but I tried using another method with string replace and I removed the H and M and I use this regress to be true. So I still got a good value, but the downside is that my value is now in whole number rather than it should be in decimal number. You can see this is 5.4, probably 5.4 hours, and this is showing 5 hours 25 minutes. That is downside. I'll definitely look for the solution later. I just have to move ahead for now. Then we convert a column to float data type, which is we use the as type to float. We use a line of code. So we plot the histogram of duration values, and you now have a good understanding of what I'm trying to say. If I run the code and see, you see the histogram is in the duration is in tens, and the count is in of hundred and thousands. Rather, you get my point. If I run similar line of code here, based on that, it's coming up. You see, my duration is showing very, very badly. I have to go back. Oh, hold up. Mm, let's see. I converted it to float data type here, and I review the column one more time. You can see the results here. Let's see. Uh-oh, that's bad. So you can't convert 19H to floats. You have to use another duration column there. Hold on a minute. I believe we actually removed this, right? So this will show us voila better. You can see now. So when I move the H and name, I should have this result, and I can visualize it better. You can see. Then let's see another a better visual. You can now look at the result I have here. You can see it is in thousands because of my data type conversion. So that was a challenge, and I was trying to make sure I get it exactly as it is, but I couldn't for now. So I'll just go ahead and move forward. I know that it's just a little bit of error here based on the conversion. I have to convert this to decimal. This hours, I have to convert it to decimal hours. That is, I know what the solution is, just don't know how to get it done yet. You can see the count is correct. My count is correct with what we have here. My duration record are incorrect. But for now, we just have to make do with that. Then we can continue later. Okay. Let's continue. So let's move on. Adding descriptive statistics. Now, duration and price both contains numeric values in the plains data frame. You will like to calculate summary statistics for them that are conditional on values in other columns. So, I want to create summary statistics using conditional column based on values from other column. Okay, let's see that. Okay. Now, price standard deviation for airline. Okay, we want to get the standard deviation for price by airline based on airline. What you see, planes, interesting. So add a column to planes containing the standard deviation of price based on airline. Okay, standard deviation of price based on airline. Mm, airline price standard deviation. Hold on a minute. Planes, that will be planes group by. I'm going to group by airlines. Okay, group by airline. For the just so easy to copy and paste. For the price column, okay. Since you want to get the standard deviation, it's going to be transformed. Turn on the lambda is yes, I want to do the standard deviation and the stormy statistics. Then STD. Let's run the code and see. And voila, so this will be our results. Interesting. Now let's do the same thing. Let's copy this line of code and make use of it in Jupyter Notebook. Okay. And what I can see, the standard deviation of price based on airline. So what use this transform lambda x and std according to the video instruction that we watched on the previous live stream. If you compare the result, we should have similar results. You see this 3685. Hopefully it will be correct because of my the duration column. That's the duration column, not the so I'm using the airline and price column. So I should have correct results. Hopefully, let's see. 4 to 13. Hmm. First Airways is Jet Airways as sorted. Let's see the data type for the results. Int. But let's move on for now. Probably our data sets are not both correct. Now calculate the median for duration by airline. Oh, this will probably have error in results based on my own data points. Calculate the median for duration by airline, storing it as a column named airline median duration. We're going to follow similar results. That is grouping by, that would be planes duration, planes data frame, then group by duration, for the airline, so it should now be dot transform, lambda x x. We have the median. That's median. So we want to calculate the median. Let's run the code. Ooh. Mm. Air India to America. Yes, in Air India. Let's get up on the error. It's saying cannot convert Air India to numeric. Oh, probably one of the data point there. This similar results. I wrote similar line of code. On airline, not the the group should be done on airline. Okay. So my mistake was using grouping by the grouping should be done on airline. Group by airline, then duration, yeah. That was my mistake. The duration is a numeric variable, yeah. Sorry about that. Voila. You see my result now. Grouping by the wrong categorical variable. Let's see. See our result here. Median duration by airline. Interesting. Let's submit and see. Now, finally, find the mean price by destination, saving it as a column called price destination. So similar results, the mean price, similar scenario rather. Hold on a second. Now let's do similar results for this, which is transform. Then going to be lambda. Find the mean, then the mean. Voila. So we got similar result. Mean price by destination. Let's see. I see the mean price destination mean. Interesting. So terrific transform look like Jet Airways has the largest standard deviation in price. So consider that the Jet Airways has the largest standard deviation in price all the way from here also. Exactly. Air India has the largest median duration. Air Indian has the largest median duration. Let's see. Median duration. Air Indian. That's showing Jet Airways here. Now finally it says New Delhi on average is the most expensive destination. New Delhi. Oh, sorry, my data point is wrong then. Definitely data point I'm working with is quite different from what they have here. But I have similar result though. I is now New Delhi. Oh, based on this mean. Oh, interesting. Let me take a better look again. It says, looks like Jet Airways has the largest standard deviation in price. Jet Airways, largest standard deviation in price. I see 415 over 400. Okay, that is correct. And it says Air India has the largest median duration. Air Indian, largest median duration. That's absolutely correct also. Is 1, 2, less than the rest. Oh, that's correct. Then finally, New Delhi on average is the most expensive destination. New Delhi, most expensive destination. 524. Hmm. All these data points are larger. Hmm. I can't corroborate that. But let's move on. So actually learning, it doesn't have to be 100% perfect. Let's see how to undo outliers now in in Python.
Let's look at how to handle outliers. To recap, an outlier is an observation that is far away from other data points. If a house prices dataset has a median of $400,000, a house that costs $5 million would likely be considered an outlier. However, we should consider factors that affect price, such as location, number of bedrooms, and overall size. A starting place for identifying outliers is with the pandas.describe method. We can see that the maximum salary is more than 4 times the mean and median. Seems extreme, right? We can define an outlier mathematically. First, we need to know the interquartile range, or IQR, which is the difference between the 75th and 25th percentiles. Recall that these percentiles are included in box plots, like this one, showing salaries of data professionals. The box contains percentiles, and observations considered to be outliers are represented as diamonds outside of the box. Once we have the IQR, we can find an upper outlier by looking for values above the sum of the 75th percentile plus 1.5 times the IQR. Lower outliers have values below the sum of the 25th percentile minus 1.5 times the IQR. We can calculate percentiles using the series.quantile method. We pass 0.75 to find the 75th percentile for salary, then pass 0.25 to get the 25th percentile. We calculate the IQR by subtracting one from the other. Printing the result shows an IQR of around $76,000. We can plug these variables into our formulae to find the value thresholds, first for the upper limit and then for the lower limit. Printing the results, we can see that the lower limit is actually below 0, which isn't possible given we are working with salaries. We can find values outside of these limits by subsetting our data. It will only return upper outliers, but for the purpose of demonstrating the syntax, we've also filtered for values below the lower threshold. We also subset to just show experience, employee location, and salary USD. There are 9 individuals with a salary above the upper threshold. Notice how none of them are entry level, and they are all based in the US. So why is the detection of outliers an important part of exploratory data analysis? These are extreme values and may not accurately represent the data. Additionally, they can skew the mean and standard deviation. If we plan to perform statistical tests or build machine learning models, these will often require data that is normally distributed and not skewed. Once we know we have outliers, we need to decide what to do. It's helpful to ask ourselves why these outliers exist. For example, salaries can be very high depending on level of experience and the country of employment, so could be representative of a subset of our data. If this is the case, we could just leave them alone. Alternatively, do we know the values are accurate? Could there have been an error in data collection? If there's an error, we could remove the values. We can remove outliers by modifying the syntax we use to subset our data, filtering for values more than the lower limit and less than the upper limit. Reprinting our descriptive statistics shows 9 fewer values, a mean that is $5,000 less than before, and a much lower maximum salary. To highlight the impact of removing outliers, let's plot a histogram of the original dataset containing the outliers. We see the distribution is right skewed by the upper outliers. Plotting with the no outliers dataset, salaries is now less skewed and looks more like a normal distribution. Time for you to practice working with outliers.
Okay, so let's practice working with outliers. Interesting. Quick 1 minute break. Okay, so why do outliers? What's to do with outliers, rather? So identifying and dealing with outliers is an integral step in performing exploratory data analysis. In this exercise, you'll be presented with scenarios where outliers are present, and you need to decide what action you would take. Place each scenario into the appropriate bucket depending on what happened, should be taken, to deal with the outliers? What approach should be taken to deal with the outliers? Okay, let's decide if we are to remove outliers or leave outliers in the data sets. A basketball player average 35 points per game when the average across the league is only 10 points per game. A basketball player, he average 35 points per game when the average across the league is only 10 points per game. Hmm. Is that not outrageous? Ronaldo could score more though. Hmm. The heights of different animals are recorded, and one is more than 1.5 times the height here plus 25 percentile. One is more. Oh, come on. A participant in a study has an age of minus 35 years old. That's not possible. Countries have an average total area of 667,143 square per kilometer, but one country is recorded as 1 million. Hmm. Countries have an average. They could have just discovered new lands for the country. A temperature sensor has a recording of 100 degrees Celsius, but the sensor only functions correctly at temperatures of up to 80 degrees. A temperature sensor. Uh, let's see. And finally, a car speed is recorded as 5,000 kilometer per hour. Uh, a car speed. I don't own a car, so I may not know that pretty well. Ooh, I misplaced this temperature. So a normal temperature should function at, it will definitely function very well if it's in, even if it's in 800, 80 or 90 or whatever it is. The normal temperature should be 100. Okay, this is not logical though. I guess so. And this minus 35 years old, come on. That's so outrageous. Basketball player could be that good, of course. A player could be so good like every minute is just dropping 3 points, 3 points. It's quite possible. And they've not discover more, like I said it. Probably they've not discovered more land in that country. I couldn't figure this out pretty well though, but I tried it. Alright, let's continue. Oh, just ignore this, continue learning. Now let's identify outliers. You've proven that you recognize what to do when presented with outliers, but can you identify them using visualizations? Okay, try to figure out if the outliers in the price or the or duration column or the plain data frame. Definitely they are. My own data is skewed. Matplotlib.pyplot and Seaborn have been imported for you as PLT and SNS respectively. Let's plot a histogram of flight price. Okay, SNS is plot or the data frame is plain data frame. So plot the histogram of price. Let's plot the histogram of price. Oh, planes is not defined. Oh, small letter P. Okay, we have histogram of price right there. Okay, this doesn't look like a normal distribution, but it is skewing to the left. You can see there are more data points on the left. Definitely, there's an outlier in the data set. Quick break. Less than a minute.
Hello? Hello? Morning. I'm fine. No look up since. I won't, I won't beg you to make help. I won't beg you to make help my ministry.
I'm back. Sorry about that. I had to pick that. So now we just discovered that there's definitely an outlier in this data set, in this data point, the price column that we've just actually visualized. So this is the price column, what it looks like. Okay, I'm gonna say that's it. These are non-numerical data points. The price column, this price column here. So let's submit and see. Display the descriptive statistics for flight duration. Flight duration. Oh, come on. My flight duration is quite different. And that will be kind of, let's display the descriptive statistics. Points by duration. That will be planes. Data frame. The price, the duration column. Come on. Am I having my ads in my code tele? Duration. To describe. Let's describe the descriptive statistics for that column. Like I see the descriptive statistics, we probably will see it better in this place. Let me just show you right here. The count is 8,000 rows, the mean, the standard deviation, minimum value, and the max. You can see the maximum value is almost is like 1 million times higher than the minimum value. You see, that's for my duration column. Probably that is wrong. Let's check here though. Similarly, we pay attention here. Look at the minimum value of 0.083. Look at the maximum value of 47. Definitely there is an outlier there. Okay, let's submit and see. So which column potentially contains outliers? Hmm. If you say between the price column and the duration column, potentially, hmm, that's kind of tricky. If you want to do justice to that, I'll probably just visualize this duration column on Instagram also. Let me just do that real quick. Let me just do it for doing sake. Even though my duration column here is not correct. Okay, let's see. Mine is definitely not correctable. It is still closer to this. Mine is not correct here though. I'm definitely going for the price column. If we say price and duration, they both contain outliers. There's no line, there's no uh denying that. So impressive outlier detecting histograms, block plot, and descriptive statistics are also useful methods for identifying extreme values. And let's deal with them. So you can see that this for the price column, this histogram is skewed to the left. It doesn't look like a normal histogram that will be centered. You can see that the price column here, this duration column here, the minimum value is quite low, while the maximum value is quite so high, according to the video lesson though. Let me just check that again. Exactly. So you could detect outliers within the minimum and the maximum value in your data set. So let's continue. So removing outliers. Why removing outliers isn't always the way to go for your analysis. We decided that you will only include flights where the price is not an outlier. Okay, let's see. This is the last challenge here. Therefore, you need to find the upper threshold and then use it to remove values above this from the plains data frame. Okay, find the 75th and 25th percentile, saving as price 75th and price 25th. Okay, now let's look for how to find the 75th percentile. This is 70th percentile is the plains data frame. Plains data frame, price column. My price in actualiter. The price column dot quantile. We use the dot quantile. Quantile. They want the 75th percentile. That is 0.75. Same scenario. Let me just copy this real quick. I'll just change this one to 25th on the line of code. That should be fine. Let's do the same thing here. Okay. Copy this description here and save it here also. Just for my explanation's sake. Now calculate the IQL, storing it as price IQL. So just subtract the 75th minus the 75th. Price 75th minus price 25th. That should give us the IQL. Okay, we have the IQL already. Now calculate the upper and lower outlier threshold. Upper and lower outlier threshold. That'll be 75th. Price 75th plus 1.5. times the IQL. Same thing, lower threshold. That should be 25th, price 25th, minus 1.5. That is the price IQL. Okay, we have that. Let's on the line of code also. That's correct also. Now let's submit this. I finally remove the outliers from planes. Now let's remove the outliers from planes. Let's see. This is the last part. We need to say subset the data planes data frame planes in the price minus the lower threshold and planes this is greater than the lower threshold and lesser than the upper threshold. That should then remove that for us. Let's see. Okay, so this one is saying this subset means remove the outliers. So that's what we're actually doing there. Now if you run the code then describe, you should have a better data points now. And let's do the same thing right here for the price column. Voila, we should have a better data point now. You can see, okay, the maximum is 2,300. I'm having something less than here. The minimum is 1759. Definitely quite different though. I have the minimum of 1759 here. 1759. The maximum is 2300. 22, quite close. Interesting. Probably my data point is definitely a lot difference. Let's submit and see. Ridiculous outlier removal skills. You manage to create threshold based on the IQL and use them to filter the planes dataset to limit extreme price. Originally, the dataset had a maximum price of 55,000. You can see, let's check. Can see the price. This is the duration column. No, where is the price? Can see the 55,000. Probably, yeah, this 55,000, yeah. You look at these data points here. This is the price column. That's correct. But the output of the planes of the scribe shows the maximum has been reduced to around 2,300, reflecting a lesser skew distribution for analysis. Wow, we've learned something new. Interesting. Okay, let's start chapter 3. I think we still have quite a lot of time here. Let's see patterns, relationship in data. So variables in data sets don't exist in a vacuum. They have relationship with each other. So data set has relationship. Probably they are trying to say one columns have relationship with the other column. Okay. In this chapter, you look at relationship across numerical, categorical, and even date time data, exploring the direction and strength of this relationship, as well as ways to visualize them. Hmm. Okay, let's start with chapter 3. We don't have much time to learn. I'm happy we were able to solve the last challenges a little bit. Let's take a quick break. Okay, so let's start this chapter 3 of the course, relationship in data sets. Okay, so for every chapter, I always love to create a new chapter notebook. This is quite long, you can see. This was for chapter 2. So I'll just go back here and create a new data points, a new chapter notebook rather. And I'll call it the first thing I always do is to copy all these libraries because we're going to use them again. Just name this EDA in Python and chapter 3. Just simple naming convention there. So you can see it here if I refresh, reload this page. I have my file there. There's probably an error going on with my directory. So I'm supposed to have all of this in so far number 10 folder here. I don't know why I'm not having that. I'll solve that. I'll troubleshoot that later. So let's start chapter 3. Let's go.
When data includes dates or time values, we'll want to examine whether there might be patterns over time. To illustrate, we'll be working with a subset of a dataset about divorce filings taking place in Mexico from 2000 until 2015. This data contains columns for marriage date and marriage duration in years. Before we can begin to look at potential patterns over time, we need to help pandas understand that data in a given column is in fact date or time data. When a CSV file is imported into pandas, date and time data are typically interpreted as strings, as we see here. We can fix that by adding the parseDates keyword argument to the CSV import and setting it equal to a list of column names that should be interpreted as date-time data. Now, when we check the data types of the imported CSV, the indicated column is a datetime object. This data type opens up many possibilities for analysis, such as looking at patterns over years, months, or even days of the week. Of course, we may wish to update data types to datetime data after we import the data. This is possible with pd.toDateTime, which converts the argument passed to it to datetime data. Here, we pass the marriage date column with values stored as strings to pd.toDateTime. This returns datetime data, which we save as the new marriage date column. pd.toDateTime has lots of other useful functionality. For example, if a data frame has month, day, and year data stored in 3 different columns, as this one does, we can combine these columns into a single datetime value by passing them to pd.toDateTime. Note that for this trick to work, columns must be named month, day, and year, but can appear in any order in the data frame. Conversely, we might want to extract just the month, day, or year from a column containing a full date. If data is already stored in datetime format, as marriage date is, we can append .dt.month to extract the month attribute, for example. We'll save the month data as a new column in the data frame so that we can use it in our analysis. Line plots are a great way to examine relationships between variables. In Seaborn, line plots aggregate y values at each value of x and show the estimated mean and a confidence interval for that estimate. Perhaps we'd like to check whether there is any relationship between the month that a now divorced couple got married and the length of their marriage. We can set x equal to the marriage month column and y equal to marriage duration. The results show some variation in mean marriage duration between months. The blue line represents the mean marriage duration for our dataset, while the confidence intervals in the lighter blue shading indicate the area that, with 95% probability, the population mean duration could fall between. The wide confidence intervals suggest that further analysis is needed. It's your turn to practice working with date-time data with a larger divorce dataset.
Okay, so let's see how we can work with these data sets. Let's get our hands dirty, 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 dirty. Let's go. Okay, importing date time data. Let's see the data set I have here. Let me just connect to it in my Jupyter notebook. Let's see. So I have the default data set here. Let me just copy this line of code real quick. So this is not the visual where I connect to the data set. This is this long line of code. I'm currently having a little bit of challenge with my file paths, so I don't know what to do with that yet. Let's make use of this for now. Divorce, I have that there. Just change this to divorce. Divorce. Let's go. Okay, now let's call on divorce and see what we have here. And voila. We have the divorce dates, the TOB man. We don't know what that means. Date of birth man. Okay, probably date of birth of the man, education of the man, income of the man, date of birth of the woman, education of the woman, income of the woman, the marriage dates, the marriage duration, and number of kids before the divorce actually happened. That's an interesting data set to work with. Over 2,000 rows of data, then 9 columns. Ooh, I can't wait when I start visualizing and working on my project. I have quite a lot of data sets to work with. Let's just call on a few number of rows, just something simple like this. Okay, interesting data points here. Now, we actually don't know what the data type looks like. I should just get that with the summary statistics or the describe function. But let's move ahead. So you will now work with the entire divorce data set. The data describe Mexican marriage dissolved between 2000 and 2015. It contains marriage and divorce dates, educational level, best income for each partner, and marriage duration, as well as the number of children the couple had at the time of divorce. The column names and data type are as follows. Interesting. The divorce date is an object, which is wrong. It's supposed to be a date point data set. The date of birth of the man is an object, wrong. Education of the man, income of the man, and so on. So it says it looks like there's a lot of date information in this data that is not yet date time data type. Your task is to fix that so that you can explore patterns over time. So import divorce CSV, saving as data frame divorce. We've done that. Let me just save it as small letter divorce. Oh, I did that actually. Interesting. Okay. Now indicate in the import function that the divorce dates, date of birth of woman, and marriage date column should be imported as date time values. Oh, okay, let's do that. Okay, divorce data types. Okay, we can just check the data type also here, just for learning sake. TT types. Let's see, is it all data type? Oh, objects. Now we have what the data type looks like. You can make better informed decision based on the information we have now. Okay, let's see. So it says divorce dates, import divorce, passing the appropriate column as dates in the import. Okay. Let's see PD underscore we can actually convert the date time, the data types of each column while importing. Also do that after importing using the dates pd.datetime function. Let's do the first one first. PD read underscore CSV. The data frame is divorce. Divorce.csv. Then pass dates. Pass dates equals to, and I mentioned the column I want there. So import the data, send data frame as divorce. Okay. Indicate in the import function that the divorce dates, that's the first one. Date of birth of married and the married date column should be inputted as date values. Let's copy all of this. Let's get rid of the and keyword there. So I'll just add my quotes here. My quotes there. My quotes here. My code there. My quotes here. Okay, we're on track. Let's see. Okay, just a second there. Now let's see. Let's run the line of code and see. Ooh, PD dots. Oh, so PD dots. Let's run the line of code again. Voila, you can see now our divorce date is now date time, man, education. No, we didn't mention education. Divorce dates, date of birth of man, date of birth of woman, and marriage dates. They are now date time. Now let's convert my own data point also within here to similar case. I think I can do that here. Let's do that while within the line of code. Let's see. Let's see. Let me copy this. Let me copy that and do it also in the same scenario. Comma. As you have passed dates into the line of code here. Pass dates, divorce date, date of birth, married dates. The moment of truth. No error. You can see my initial data type rather are this. You can see. Now if I run this line of code, you can see the data points. No error. And voila. It works. So that's how you convert column data type to different data type initially when you're importing them. Interesting. But I wanted to try another method though, but this method also worked fine. Now let's submit and see. Bingo. Nice work pressing those dates at the same time as you imported the data into pandas. Next, have a go at updating datetime data types in data frame that has already been imported. Okay. Now let's update data type in data frame that has already been imported. So that was the second method I was trying to use. Updating data type to datetime. Now the divorce data frame has been loaded for you, but one column is stored as a string that should be datetime data. Which one is it? Once you identify the column, you update it so that you can explore it more closely in the next exercise. But that should be the, let's see, let's take a closer look. Mm, we have divorce dates, date of birth of man, date of birth of woman, okay, income of woman. That should be the marriage dates. Oh, hold on. Let's take a closer look. Divorce dates, date of birth of man is the date, date of birth of woman, marriage dates. Ooh. Then what data point is needed? What column is needed to be in dates? Let's take a closer look. It's not divorce date, definitely not the divorce dates, not the married date, not the marriage dates, education of woman, number of kids at the daytime. No way. Let's see. That is wrong. Is the number of kids also makes sense. There's no education of woman. But these two have been imported at the date time. So why you not giving me same scenario also? Did we include married dates in this place? Divorce dates, date of birth, married dates, yes, is included. Oh, hmm. But the married dates is included already though. Let me see. So I think marriage dates. Marriage date that is already a date time here. Marriage dates. Where is that? Marriage dates. Marriage dates is a date time already. Yes, DataCamp is something's wrong with them on their head. Okay, now convert the married dates column or the divorce date time to date time values. We're going to use another method using the pass PD to date time variable. I'm going to say PD to date time. So divorce the married dates column, let's say PD on that dot to date time. Divorce and the marriage dates column. So this is the second method to use on code. Submit. Nailed it. Now you are set up to look at how a couple's married date is related to other data. Interesting. So let's continue from here. Our married date is already a date time here, so we don't need to do that again in this instance. Okay. Now let's visualizing relationship over time. Now that your dates data is saved as date time data, you can explore patterns over time. Does the year that a couple got married have a relationship with the number of children that the couple has at the time of divorce? Your task is to find out. So does the year they actually got married, does it have a relationship with the number of children that the couple has at the time of divorce? Okay. The divorce data frame with all dates formatted as date time data type has been loaded for you. Pandas has been imported as PD. Matplotlib is already loaded, and Seaborn has been loaded as SNS. Now define the marriage year column. Define the marriage year column. What does that mean? Marriage year. Cool. Once we start a new column called marriage year, you can see that we don't have marriage year in here, but we have the marriage date. So we need to extract the marriage year column. Oh, interesting. Let's extract the data from that point. So a new column we call marriage year, which is going to be from let's extract that. That will be marriage year and the divorce data frame. Want to extract from the marriage dates column. Want to extract dt dot year. So we have that already. So we have the marriage year. So we should have a new column called marriage year now. I call on my divorce data frame real quick. Voila. So we have the marriage year. You can see we have a new column called marriage year right there. So let's continue. Now create a line plot showing the average number of kids a couple had during their marriage, arranged by the year that the couple got married. Okay, let's create a line plot. WSNS dot line plots or data source, the divorce data frame. Create a line plot showing the average number of kids. Also the average number of kids. Average. Let's see what we have here. That's the mean number of kids. Our x variable is going to be marriage year. Why is my keyboard changing to UK? Marriage year. Then our y variable is going to be the number of kids. His name of num kids. Let's see what we have here. Voila. You see? But it's also giving us the average number of kids. Okay, let's see. Let's see it here also. You can see the years, average number of kids. See those in 19 that got married in 1970, they had three kids compared to those that got married in 2010. Ooh, those that got married in 1975 had over, is it supposed to have 3.5 kids? That's possibly not wrong. Probably one of them, one of the parents got married to somebody else. Let's see. Nice. You discovered a pattern here. It looked like couple who had later marriage years also had fewer children. You can see during their marriage. We'll explore this relationship another further in the next video. Yeah, you can see couple that got married in the later years. They have lesser number of kids. What's wrong with them? Come on. I think the older couples had more kids than we young couples. Let's continue. Let's learn about correlation. Oh, let's learn about correlation here. I will definitely be stopping here today. Or if you can complete this today, that would be interesting. Let's go ahead. Okay.
Getting a sense of relationships between variables is important for evaluating how data should be used. That's where correlation comes in. Correlation describes the direction of the relationship between two variables as well as its strength. Understanding this relationship can help us use variables to predict future outcomes. A quick way to see the pairwise correlation of numeric columns in a data frame is to use Panda's .core method. A negative correlation coefficient indicates that as one variable increases, the other decreases. A value closer to 0 is indicative of a weak relationship, while values closer to 1 or -1 indicate stronger relationships. Note that .core calculates the Pearson correlation coefficient, measuring the linear relationship between two variables. Let's wrap our divorce.core results in a Seaborn heat map for quick visual interpretation. A heat map has the benefit of color coding, so that strong positive and negative correlations, represented in deep purple and beige respectively, are easier to spot. Setting the init argument to true labels the correlation coefficient inside each cell. Here, we can see that marriage year and marriage duration are strongly negatively correlated. In our dataset, marriages in later years are typically shorter. However, this highlights an important point about correlations. We must always interpret them within the context of our data. Since our dataset is about marriages that ended between 2000 to 2015, marriages that started in earlier years will by definition have a longer duration than those that started in later ones. We also need to be careful to remember that the Pearson coefficient we've been looking at only describes the linear correlation between variables. Variables can have strong nonlinear relationship and a Pearson correlation coefficient of close to 0. Alternatively, data might have a correlation coefficient indicating a strong linear relationship when another relationship, such as quadratic, is actually a better fit for the data. This is why it's important to complement our correlation calculations with scatter plots. For example, the monthly income of the female partner and the male partner at the time of divorce showed a correlation coefficient of 0.32 in our heat map. Let's check that this correctly indicates a small positive relationship between the two variables by passing them as x and y arguments to Seaborn's scatterplot function. It looks like the relationship exists, but is not particularly strong, just as our heat map suggested. We can take our scatter plots to the next level with Seaborn's pair plot. When passed a data frame, pair plot plots all pairwise relationships between numerical variables in one visualization. On the diagonal from upper left to lower right, we see the distribution of each variable's observations. This is useful for a quick overview of relationships within the dataset. However, having this much information in one visual can be difficult to interpret, especially with big datasets, which lead to very small plot labels like the ones we see here. We can limit the number of plotted relationships by setting the var's argument equal to the variables of interest. This visual reassures us that what our correlation coefficients told us was true. Variables representing the income of each partner, as well as the marriage duration variable, all have fairly weak relationships with each other. We also notice in the lower right plot that the distribution of marriage durations includes many shorter marriages and fewer longer marriages. Now, it's your turn to search for relationships in the divorce dataset.
Okay, now let's look deeper for relationship in the divorce datasets. Okay, interpreting a heat map. So which of the below statements is correct regarding the relationship between variables in a divorce data frame? The divorce data frame has been loaded. We know all of this. Let's see. Marriage duration is strongly positively correlated with marriage months. Marriage duration. Let's see. We won't take that. Should we use heat map or scatter plots? Let's do scatter plots. It says marriage duration. Married months. Let's see. Oh, hold up a minute. Okay. I'll go ahead and copy this and make use of it in my own machine here. Let's see what we have here. Marriage duration. Oh, let's change this here. Oh, marriage months. But there's no married months. Okay. I have to create a new column called married months. Wait, hold up. Let's refresh this. While this is refreshing, we have to create a new data point called married months. Okay. Let's extract. So let's go up here. Define married months column. So married year, married dates, married months. Sorry, married months. Then we have to extract the months from that column. We've done that. Now we have married months. You see, married months, married duration. Oh, what is this? I can copy this. There's not even married months in our data frame. This should be wrong. I have to create a married month in that instance. You see, married month, married duration. I have same results, but wrong information. Yeah. Even if you don't have married month, we already have a married month already. I already created it, but are they correlated? No way. Is it strongly positively correlated? That's the question mark there. Let's try for correlation between number of kids and income man is stronger than correlation between number of kids and married duration. Oh, and let's try the two. Let's give the two a shot and see our results here. To make it easier, I'll just copy this. I'll just make sure it's pretty fast. Income man between number of kids and income man. Let's see. Amount of truths. Ooh, come on. Now let's take the second one. Then the last one say number of kids and marriage duration. Let's see. Ooh, quite similar, but the opposite. Now let's see the last one. A later marriage year causes a lower number of children represented by number of kids. Ooh. So the correlation between number of kids and marriage duration is stronger than the correlation between number of kids. So number of kids and marriage duration is stronger, which is a negative, stronger relationship. Weak correlation. Marriage duration is strongly positively correlated to marriage months. As you can see here, wrong. Then the married later equates to having fewer number of children. Exactly. Well done. It does not appear that a later marriage year is correlated with having fewer number of children. As a later marriage year is correlated with having fewer children. That's it. So that's quite a lot of. Now let's create visualizing variable relationship. So in the last exercise, you may have noticed that a stronger you may have noticed that a longer marriage duration is correlated with having more children, represented by the number of kids column. The correlation coefficient between the marriage duration and number of kids variable is 0.45, which is slightly correlated and higher. In this exercise, you create a scatter plot to visualize the relationship between these variables. Okay, let's visualize the relationship between marriage duration on the x-axis and number of kids on the y-axis. The correlation, okay, correlation between number of kids, marriage duration on the x-axis. Oh, I just swapped in. A number of kids on the y-axis. Let's see. Ooh. So similar results here. You could see relationship, marriage duration. The longer the marriage duration, the higher the number of kids. Okay. Interesting results. Okay. Bingo. There's a slight positive relationship in your scatter plot. In the data set, couples with no children have no value in the number of kids column. If you are confident that all or most of the missing values in the number of kids are related to couples without children, you could consider updating these values to 0, which may increase the correlation. Interesting. Consider we have a number of kids record with NANA. It's better we update them to 0, so our correlation begins to be more positive than this. Interesting. Okay. Oh, we spent almost an hour, 30 minutes on the live stream. Ooh. Now, let's complete this last part of the challenge. Oh, we have a couple of more challenges to go. Visualizing multiple variables relationship. Okay, let's see. Let's say visualizing multiple variable relationship. Seaborn.pair plot. Can we use the pair plot for that? Is excellent for understanding the relationship between several of all variables in the data set by aggregating pairwise scatter plot in one visual. Task is to use the pair plot to compare the relationship between married duration and income woman as okay, let's compare the relation between married duration and the income woman. SNS dot pair plots. Let's do the pair plots. Our data points, our data frame is the divorce data frame. I want to look at these two variables against each other. And the income woman. Now let's see. Voila. Let me copy this and see. Let's see the results in my Jupyter notebook here. Voila. Ooh, look at the married duration and the married duration against each other, but the income woman against married duration. Ooh, ooh, pair plots. PARPLOT, PAIRPLOT. We did. Income woman. Oh, I brought it against each other. Supposed to be income woman first. Income woman first. So that is the first thing here. My mistake. Let's do it better now. Voila. Now, the opposite of each other. Similar result, but opposites. Well done. Just as in the correlation matrix, you can see that the relationship between income woman and married duration is not a strong one. You can also get a sense of the distribution of both variables in upper left and lower right plots. Upper left, upper left, and lower right plots. This information is giving us the distribution of the variables. Okay, okay, let's finalize this last part on the factors of relationship and distributions. Okay, let's see.
We previously looked at relationships between numerical variables. Of course, categorical variables or factors also have relationships. We haven't explored the categorical variables related to education level yet. Let's fix that. Checking the value counts for education man, we see that most men have an education level between primary and professional, with a few men in the none or other categories. Categorical variables are harder to summarize numerically, so we often rely on visualizations to explore their relationships. Perhaps we are interested in the relationship between marriage duration and the education level of the man in the dissolved marriage. We could begin by making a histogram of the distribution of marriage duration, and then layer in the information we have on male education level by setting education man as the hue argument. The resulting histogram reinforces what we saw in value counts. We have a lot of information on males with professional level education. However, because the education levels are stacked on top of each other, the relationship between marriage duration and male education level isn't super clear. Seaborn's kernel density estimate, or KDE plots, address this issue. Similar to histograms, KDEs allow us to visualize distributions. KDEs are considered more interpretable, though, especially when multiple distributions are shown, as they are here. Notice that the location of the peak marriage duration for each level of the male partner's education is more identifiable in this KDE plot than it was in the histogram. However, due to the smoothing algorithm used in KDE plots, the curve can include values that don't make sense, so it's important to set good smoothing parameters. Here's an example. Zooming in on the KDE plot showing the distribution of male education levels, we can see that the distribution seems to suggest that some couples had marriage durations of less than 0. That's impossible. To fix this, we can use the cut keyword argument. Cut tells Seaborn how far past the minimum and maximum data values the curve should go when smoothing is applied. When we set cut equal to 0, the curve will be limited to values between the minimum and maximum x values. Here, the minimum and maximum values for marriage duration. The plot now shows only marriage durations greater than or equal to 1 year, the shortest marriage duration in the dataset. If we're interested in the cumulative distribution function, we can set the cumulative keyword argument to true. This graph describes the probability that marriage duration is less than or equal to the value on the x-axis for each level of male partner education. Perhaps we are interested in whether divorced couples who got married when they were older typically have higher levels of education. We can create columns representing the approximate age at marriage for men and women by subtracting each partner's birth year from the marriage year. Then, we create a scatter plot using these variables on the x and y axis. It looks like there is a positive correlation between them. Indeed, the Pearson correlation coefficient is 0.69, but the x and y values in scatter plots must be numerical. How do we introduce education level into our visual? One way to do this is to set the hue argument, which assigns a color to each data point based on values in a given column. Here, we set hue equal to education man. The results suggest that men with a professional education level, represented with orange dots, may tend to get married later. Now, it's your turn.
So those are the professional education level are definitely seeking more education and got married late. Hmm. That's a speculation. Okay, let's finalize this last challenge. This last two challenge. It says in the video, we explored how men's education and age as married related to other variables in our data set. The divorce data frame now. Now you will take a look at how women's education and age at marriage relate to other variables. So we figure out how the age and marriage age of the education men relate to other variables in data sets. Now let's check how women's education and age at marriage relate to other variables. Your task is to create a scatter plot of each woman's age and income, layering in the categorical variable of education level for additional text. Let's create a scatter plot that shows women's age marriage on the x-axis and income women on the y-axis. Each data point should be colored based on the woman's level of education, represented by education women. Okay, now we need to create a new column called women age marriage. when the age the woman actually got married. Let's create a column called women age marriage. With divorce. So the man age marriage from the marriage year minus the date of birth. You get the result that we have here. Now let's go on the divorce column. Who divorce. Okay. Now we have the age. Let's come here and see the age. The man age marriage, the woman age marriage. You can see we have our data points there. So how did you get that? We subtracted the marriage year from their date of birth after extracting the year from their date of birth. Did you get that? Now let's see what we can do with this information. So it now says create a scatter plots. Scatter plot of women age marriage on the x-axis, women age marriage, and the income man on the y-axis. Income of the woman rather on the y-axis. On the y-axis, each data point should be colored based on woman's level of education. So we have going to have a U line of code that will be equal to education of woman. Let's see that. And voila. Let's see. Boom. You can see the education of women. You can see those that had education level of professional. Their income is kind of lesser, and their age of marriage is higher. It's positively correlated. Let's see. Mm, okay. Also, it looks like there's a positive correlation you can see between professional education and higher salaries. As we might expect, the relationship between women's age at marriage and education level is a little less clear. Okay. Let's continue. Then finally, let's go to KDE plots. It is less clear. So this KDE plot is going to show us more information about the relationship between this woman, income of the woman, and their age of marriage. Okay. Now, create a density estimate. Let's create that. KDE. So create a KDE plot that shows married education on the x-axis, and a different colored line for each positive number of children that a couple may have, represented by the number of kids. Okay, let's see. It says create a KD plot that shows marriage duration on the x-axis and a different colored line for each possible number of children that the couple might have represented by a number of kids. Let's see this in action. Oh, can see the number of kids there. Let's see this if we can get similar results here. Boom, we got it. Now what we need to do is just here. Let me just copy this line of code here. Okay, so we have our KD plot already. Let's submit and see. Notice that the plot currently shows married duration less than 0. Can see less than 0, which is not possible. Update the KD plot so that married duration cannot be smoothed past the extreme data point. I just add the cut of 0, add the cut function, cut is equal to 0. You can see, so it's going to ignore the minimum value. You're going to start from the lower value there. Let's see. It's similar. It's not possible that the marriage year should be less than 0. So you have a much more better plus now. Okay, and one more thing. So goal is to update the code for the KD plots from the previous step to show cumulative distribution function for each number of children a couple has. So cumulative will just be equal to 2. Cumulative equals to 2. Let's submit that. Oh, hold up. Cumulative. That should be the single M, not double M. Oh, voila. If you see the KD plots, see much more better information from there. Oh, then the number of kids is going to increase over time. Let's see. Well done. It looks like as though there's a positive correlation between longer marriage and more children. But of course, this doesn't indicate causation. You can also see that there's a much lesser data on couples with more than 2 children. This helps us understand how reliable our findings are. Oh, interesting. Oh, so we completed chapter 3 of this. Interesting. We're definitely stopping here today and we continue from here on day 70 as we tackle turning exploratory analysis into action. So we can see what we can do with our data sets further. Okay, so that will be the end of the live stream for today. Alright, so thank you for staying to the end of the live stream. If you enjoyed this learning journey of Python with me, do well to support the channel by giving the video a thumbs up, hit that subscribe button, and I'll see you on the next video on the channel and on the next live stream tomorrow. Have a wonderful rest of the day. Bye bye.